Hello. Today we will see questions from GATE Mathematics. We'll see some concepts and we will also solve some questions from the chapter Numerical Methods. Numerical methods is one of the most important topics from GATE examination. So now today in this video we will see some basics from numerical methods and we will particularly see bisection method. So the question here is why numerical methods? Okay, to answer this question, the most important thing is if we suppose have an equation like ax square plus bx plus c is equal to 0. To solve this equation, we do like minus b plus or minus root of b square minus 4ac by 2a x is equal to, right? So if we put the coefficients correctly, then we'll get the value of x for which this equation is 0. But what if we have something like x e power minus x minus sin x is equal to 0? We want to solve an equation like this. What do? We don't have a ready-made formula for this. So therefore, we use some numerical method techniques for solving such equations. So in the later slides, we will see some of those methods. Uh, as far as GATE syllabus is concerned, generally these 5 techniques are most important and are frequently asked. They are bisection method, regular falsy, Newton-Raphson, successive approximation and secant method. Today we will see these bisection method. We'll solve some questions as well so that we get an understanding of what it is. Now, what is bisection method? So when we are given a problem from bisection method, we will be given a value of f of x and we will be given an interval a, b. So if this is the number line and we have two values a and b, so f of a should be less than 0, that is negative, and f of b should be greater than 0, that is positive. If this is the case, then the solution xi is equal to a plus b by 2, meaning this is f of a, this f of a is negative, this value f of b is positive, then the value of x, which will be the solution of this f of x, will lie somewhere in between a and b, somewhere here, and it is an iterative process. That's why I have written xi. What all these things actually mean will be very clear once we solve a question. Now this is the first question. Find the fourth approximation to the root of a function f of x. We have been given a function f of x as x cube plus x minus 11 using bisection method in the interval 2 and 3. So basically whenever you are being given a question from bisection method, you will have an f of x and you will have an interval. So as I was saying in the previous slide, now this is 2, now this is 3. So now first of all we have to make sure we have to find f of 2 is equal to what? 2 cube plus 2 minus 11 is what? 2 cube is 8 plus 2 minus 11. This is what? 10 minus 11 is equal to minus 1. So f of 2 is less than 0, that is negative. Now let us find f of 3. F of 3 is what? 3 cube plus 3 minus 11. 3 3 is 9, I was at 27 plus 3 minus 11. This is 30 minus 11 and this is 19. This is positive. Therefore root will lie in between 2 and 3. Therefore root will lie in between 2 and 3 and the value is xi is equal to a plus b by 2, that is 2 plus 3 by 2 is equal to 5 by 2 is equal to 2.5. Now f of x is equal to x cube plus x minus 11, x1 is equal to 2.5. So we have 2, we have 3, and we have 2.5. Now x2 is equal to 2 plus 2.5 by 2. Now we find that f of 2 is negative value. And what is f of 2.5 is 2.5 whole cube plus 2.5 minus 11. This comes down to 7.125. So this is a positive value. So 2 is a negative and f of 2.5 is positive. So our solution will lie in between these two. So x2 is 2 plus 2.5 by 2, that is 2.25. Now we have to find f of 2.25, that is 2.25 whole cube plus 2.25 minus 11. This comes down to 2.64. This is a positive value. So we started with 2, 3, then we had x1 is equal to 2.5, then we had x2 is equal to 2.25. Now x3, right? x3 is equal to 2 plus 2.25 by 2, which is equal to 2.125. If we find f of 2.125, this value comes down to 0.72. This is once again a positive value. Therefore, our root will lie in between 2 and 2.125. So till now we have found out till x3. Now the question actually asked for fourth approximation. Now like f of x is equal to x cube plus x minus 11. x3 is 2.125. f of x3 is equal to 0.72, as we have seen. So so f of 2 is negative and f of x 2.125 is positive. So this means that this is 2, this is 2.125. So this is a negative value. F of 2 is negative and f of 2.125, this is positive value. Therefore our interval will lie in between, our solution will lie in between. So x4 is equal to 2 plus 2.125 by 2 is equal to 2.0625, and this is the answer to the question. Our in the question we have been asked to find the fourth approximation to the root. So that is, we have been asked to find x4. So the value of x4 is 2.0625. Now we will see one more question which will clarify most of the things. This question, bisection method is applied to compute root of a function. We have been given f of x is equal to x power 4 minus x cube minus x square minus 4 in the interval 1 and 9. So the method converges after how many iterations? This is the question. So we have the number line and this is 1 and this is 9. And we have to find out after how many iterations it becomes 0. Now suppose we will find f of 1 is equal to 1 power 4 minus 1 cube minus 1 square minus 4. This is 1 minus 1 minus 1, minus 1 minus 4. This is minus 5. f of 9 is equal to 9 power 4 minus 9 cube minus 9 square minus 4. This value actually comes down to 5747. So f of 1 is negative and f of 9 is positive, therefore our root will lie in between these two. So what is that value? x1 is equal to 1 plus 9 by 2 is equal to 10 by 2 is equal to 5. Now we have to find the value of f of 5. f of 5 is 5 power 4 minus 5 cube minus 5 square minus 4, and this value comes down to whatever be the value. Actually this is 5 power 4 is 625 actually. So this whatever be this thing, okay, the first value is 625 minus 125 minus 25 minus 4, this value will be positive actually. So f of 5, this will be a positive value. So what the thing is, now I have 1 and I have 5, this is positive, f of 5 is positive, f of 1 is negative, so our value will lie in between these two. So x2 is equal to 1 plus 5 by 2 is equal to 6 by 2 is equal to 3. Now our thing is to find f of 3 here as well. So as we see that f of x is equal to x power 4 minus x cube minus x square minus 4. So x2 is equal to 3, f of 3 is equal to 3 power 4 minus 3 cube minus 3 square minus 4. So this value is this is a 9 27, this is 81 minus 27 minus 9 minus 4, this value is positive. So I have 1, I have 3, so f of 1 is negative, f of 3 is positive. My solution will lie in between these two. So x3 is equal to 1 plus 3 by 4 is equal to 4 by 4 is equal to by 2, sorry. So 4 by 2 is equal to 2. So x3 is equal to 2. Now if I find f of 2 is equal to 2 power 4 minus 2 cube minus 2 square minus 4. This is 16 minus 8 minus 4 minus 4 is equal to 0. So for f of x3 is 0. So in third iteration, after how many iteration? After 3 iteration. After 3 iteration the thing becomes so basically from the last 2 questions we have understood that if suppose I have an A, this is a number line, I have 2 points A and B, and f of A is negative and f of B is positive, then the solution will lie in between A and B such that xi is equal to A plus B by 2. Now this value, now again we have to find f of, now suppose this is the first iteration, this is an iterative method, it will take time to convert. So f of x1, suppose this f of x1 is greater than 0, so in the next second iteration f of A is negative, f of x1 is positive, so our xi is equal to A plus x1 by 2. So this is A, this is x1, our solution will lie in between these two, A and x1. So in this way we have to process till we converge. I hope this is clear. This is all the basics required for bisection method. This is a type of numerical methods, and as I have explained bisection method, and as I explained earlier, why we are going for these numerical methods is suppose that we don't have solution. Suppose we have ax square plus bx plus c is equal to 0. We can directly get the answer for this by minus b plus or minus root of b square minus 4ac by 2a. But for equations like x e power minus x minus sin x is equal to 0, we will not have solutions directly. That's why we go for numerical methods. Thank you. In the next videos, we will see other techniques like regular falsy, Newton-Raphson, successive approximation, secant method, etc.